In section 10.6, which is the last section of chapter 10, we continue to solve quadratic equations, this time using one of the most famous formulas in algebra. So I'm going to let you go ahead and read this, but to cut to the chase, the beauty of the quadratic formula is its versatility. We can use it for any quadratic. So if we have ax squared plus bx plus c equal to 0, then we can solve for x through this formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully you use this so much that you memorize it, and if I ever have a tattoo made, actually no, I won't do that, sorry. So here are some tips to keep in mind. First of all, we always want the quadratic set equal to 0 to use this formula, otherwise it won't work. Be careful with your signs because you'll be working with a mixture of positives and negatives. You're typically going to get two solutions because of the plus-minus operation, although you could get exactly one solution or possibly no solution, and then pay attention to the directions. Sometimes you'll be asked for an exact answer, sometimes for a decimal, so pay attention to that. So let's go ahead and dig into some examples and see how this works. So in our first example, we already have the quadratic set equal to 0. That's good. We can identify a, b, and c then. X squared has a coefficient of 2, so a is equal to 2. B is equal to negative 5. C is equal to negative 133. So we can use our formula x equals negative b. So the opposite of b in this case is a positive 5, plus or minus, and then we're going to square that negative 5, make sure the negative is in the parentheses, minus 4 times a times c. And all of that is under the radical all over 2a, which happens to be 2. So then we crunch away 5 plus or minus the square root of 25. Remember, when we square negative, it's a positive 25. And here we're going to be subtracting a negative, which in effect is like adding a positive, and we get 1064 all over 4. So then we have 5 plus or minus the square root of 1089 all over 4. And in this case, we're in luck because this happens to be a perfect square. Lucky us. So we end up with 5 plus or minus the square root of 1089 is 33 all over 4. Now we can break this down into two separate solutions. 5 plus 33 over 4, or 5 minus 33 over 4. So in the first case we get 38 over 4. In the second case we get negative 28 over 4. And then we can simplify. 38 over 4 simplifies to 19 halves. And negative 28 over 4, of course, is negative 7. So we have two solutions. And notice we didn't have to do any rounding there. In number 2, we again have our quadratic already set equal to 0. That's good. So we can go ahead and write our formula. So the opposite of b would be a negative 2 plus or minus. So we have b squared minus 4 times a, which is 6, times c, which is a negative 1. And we're going to take the square root of all of that, all over 2 times 6. So this is equal to negative 2 plus or minus, and then we have 4. 2 squared is 4. And then we're going to subtract a negative 24, so we're adding 24 all over 12. So this is negative 2 plus or minus the square root of 28 all over 12. Now 28 is not a perfect square, and we don't want to calculate the square root because we're told to give exact answers. So we can do some simplifying here though. Y is equal to negative 2 plus or minus, and I'm going to rewrite that as the square root of 4 times 7 all over 12. So this is negative 2 plus or minus. We can factor out that 4 because the square root of 4 is 2. So we have 2 square root of 7 all over 12. And we can do a little more simplifying here because we can factor out a 2. Both this term and this term contain a 2. So we have a 2 times negative 1 plus or minus the square root of 7 all over 12. 2 goes into 2 once, 2 goes into 12 6 times. So now we have negative 1 plus or minus the square root of 7 over 6, and we can write that in two separate forms. So negative 1 plus the square root of 7 over 6, and negative 1 minus the square root of 7 over 6. And there we have our exact answer. Number 3, here we do not have our quadratic set equal to 0. We need everything to one side. So the simplest way will be to add 8, and we get 2q squared plus 8q plus 8 is equal to 0. You might recognize this is kind of special. One thing that is special about it is everything here is even, or in other words, divisible by 2. So we can go ahead and divide each side by 2. And we get q squared plus 4q plus 4 is equal to 0. And do you notice anything special about this trinomial? That quadratic is special. Let's see what happens here. We get q equals negative 4, opposite of b, plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is 4, all over 2a. So this is equal to negative 4 plus or minus the square root of 16 minus 4 times 4, which is 16, all over 2. So this is equal to negative 4 plus or minus the square root of 0, because we have 16 minus 16 gives us 0 all over 2. But of course, the square root of 0 is 0, and it doesn't matter whether you add or subtract 0. It's not going to change that value of negative 4. So we have negative 4 over 2, which gives us negative 2. Here we have only one solution. That happens when the radical turns out to contain a 0. Another way to look at this is a perfect square. This is equal to q plus 2 squared, which is why we only end up with the one solution of negative 2. Okay, now we want to round our answers to the nearest thousandth if needed. So if we get a radical and it's not a perfect square, we go ahead and calculate the square root. So here we need to add 8 to each side so that we get everything moved over onto one side, and have our quadratic set equal to 0. So negative 5v squared plus 2v plus 135 is equal to 0. Now we can use our quadratic formula. So v is equal to negative 2 plus or minus the square root of 2 squared minus 4 times negative 5 times 135. So we're going to be subtracting a negative, or in other words, adding a positive. So this is negative 2 plus or minus the square root of 4 plus 2700. All over negative, this was supposed to be a negative 5. I was jumping ahead. And this is a negative 10. So we get negative 2 plus or minus the square root of 2704 all over negative 10. And it turns out 2704 is also a perfect square. We got lucky again. So this is equal to negative 2 plus or minus, and the square root of 2704 is 52 all over negative 10. So now we can break this down into two solutions. So we have negative 2 plus 50 over negative 10, or negative 2 minus 52 over negative 10. So this is equal to positive 50 over negative 10, or negative 54 over negative 10, which gives us negative 5 or positive 5.4. And here we don't need to round to the nearest thousandth because we have an integer and a decimal that ends after one decimal place, or in the tenths place. Okay, here we want everything to one side, and actually the fastest way to do that will be to add 4g squared to each side. So it might look a little bit different because now we end up with 0 on the left hand side. That's okay. And I'm going to write this in standard form. So I'll write the 4g squared first, and then the g term, which is 8g, so plus 8g minus 17 And so now that this is set equal to 0, we can use our quadratic formula. So g is equal to negative 8 plus or minus, we'll have 8 squared minus 4 times 4 times negative 17, take the square root of that, all over 2 times 4. And this equals negative 8 plus or minus 64, and again we're subtracting a negative, so we end up adding 272 all over 8, so we get negative 8 plus or minus the square root of 336 all over 8. Now because we have an 8 in the numerator and the denominator, I'm going to go ahead and break this down into two fractions. So we're going to get negative 8 over 8 and then plus or minus the square root of 336 over 8. Or in other words, negative 1 plus or minus, and then we can go ahead and calculate the square root of 336 divided by 8. So second square root, 336, make sure to close parentheses and then do the division. Divide by 8 gives us 2.291. We're going to round at the thousandth place, which means we look to the next decimal over. It's less than 5, so we keep that as a 1. So 2.291. So in our first case, we'll take negative 1 plus 2.291 to get a positive 1.291. And in the second case, we'll take negative 1 minus 2.291 to get a negative 3.291. Okay, number 6. We need to move two terms. I'm going to go ahead and subtract 5m and subtract 10m squared. And that means we need the same thing over here. It doesn't matter what order we write it in, actually. So I'm going to line up m squared under m squared minus 5m. Just make sure you're subtracting both. So we end up with 2m squared minus 5m minus 19 is equal to 0. So now we can use our quadratic formula. So m is equal to, the opposite of negative 5 is a positive 5, plus or minus, okay, we're going to square negative 5, negative in the parentheses, minus 4 times a, which is 2, times c, which is negative 19. Take the square root of that, all over 2 times 2. So this is equal to 5 plus or minus, and we're going to get 25, and again we're subtracting a negative, so we're actually adding 152 all over 4. And so here we get 5 plus or minus the square root of 177 all over 4. And I'm going to go ahead and write that as two separate solutions. So 5 plus the square root of 177 over 4, and 5 minus the square root of 177 over 4. And now because we're asked to round to the nearest thousandth, we're going to go ahead and calculate those. So first of all, I'm going to use a parentheses, set of parentheses for the numerator. 5 plus the square root of 177. So close the parentheses for the square root, close again for the numerator, and then divide by 4. And we get 4.576. The next decimal over is less than 5, so we keep the 6. 4.576. Or in our second case, when we have 5 minus, we have 5 minus the square root of 177, close parentheses, close again, divide by 4, and we get negative 2.076. And there are our solutions, and we need to end right now, so good luck and enjoy.